Hello friends, today's question. A thin uniform circular disk of mass m and radius r is rotating in a horizontal plane about an axis passing through its center, perpendicular to its plane with an angular velocity omega. Another disk of same dimension but of mass m by 4 is placed gently on the first disk coaxially. The angular velocity of the system now is. So we are given that there is a uniform circular disk of mass m. So let us draw a disk, and it is rotating on a axis which passing through the center and perpendicular, and it is given that it is rotating with the velocity, angular velocity omega. Radius is given as r and the mass is m. Now in the second part, disk of the same dimension is placed on the original disk. So we have this as a original disk, and of same dimension another disk is placed on it, and they are rotating along the same axis. Now in this case, let us suppose that it is rotating with the angular velocity of omega f, and in this case let us write this as omega I, and omega I is equal to omega. So we can say this, let us call as initial condition, and let us call this as final condition. So we can find out the moment of inertia for initial condition. You can say moment of inertia of disk for initial condition, let us call that as I1, and I1 will be equal to half m r square. And the second case we can call it as a final condition, and the final condition now it consists of two disk which is having a mass m, and second disk which is having a mass m by 4. So you can say moment of inertia of disk which is having a mass of m, and another disk which is having a mass of m by 4 for final condition. So in this case we can say let its moment of inertia of both the disks combined is given as I, and I will be equal to moment of inertia for mass m plus moment of inertia for mass m by 4. And for mass m we have earlier calculated as 1 by 2 m r square, and for mass m by 4 we can find out, we can write it here as moment of inertia for mass m by 4 will be equal to 1 by 2 m by 4 r square, which gives us m by 8 r square. Therefore I will be equal to 1 by 2 m r square plus m by 8 r square, and you can say this will be coming as 5m r square by 8. me write it here. For initial condition, mass equal to capital M, and for final condition, mass will be M plus M by 4. Now we can use conservation of momentum, angular momentum rather. Conservation of angular momentum. So initial momentum, let us call that as L initial, will be equal to final momentum. Therefore, initial is moment of inertia is I1, so this will be I1, and we have assumed the angular velocity is omega I, and final is our I and omega F. Now it is simple. We are going to substitute the values. We get here omega F is equal to I1 divided by I omega I, and we already know that we have assumed that omega I is equal to omega, and we know the value of I1 as well as I. So substitute it here, you can say therefore omega F is equal to I1 was our half mr square and I was our 5 by 8 mr square multiplied by omega. Mr square and mr square cancels out, so you can write this equation will be coming as 8 upon this will be 2 multiplied by 5 multiplied by omega. So this will be 2 4, so we get omega F is equal to 4 by 5 upon omega. So this is the final, which we will ask, angular velocity of the system. This is the angular velocity of system. Here system means mass M plus mass M by 4. So therefore we get omega final as 4 by 5 by omega. So this is our final answer. So this completes the question. Thank you.